Hi friends, let's solve this question. Let A bar, B bar, C bar be three vectors mutually perpendicular to each other and have same magnitude. So it is given that A bar, B bar, C bar are mutually perpendicular. So what we have then? If they are mutually perpendicular, we have A bar dot B bar equals to 0. Similarly, we have A bar dot C bar equals to 0. Even A bar B bar dot C bar is equals to 0. Okay. So this is what we have. B bar dot C bar is equals to 0. So A bar, B bar, C bar are three vectors which are mutually perpendicular to each other and have same magnitude. Same magnitude means mod of A bar is equals to, or magnitude of A bar is equals to magnitude of B bar equals to magnitude of C bar. This value is same. If a vector R bar satisfies this condition, which is equals to 0, then R bar equals to. So we have to simplify this given equation to get the value of R bar. A very important point is here is that, see, R bar is a vector. A bar, B bar, C bar are mutually perpendicular. So if you have a three mutually perpendicular vectors, so any vector in the three-dimensional space can be written as a linear combination of A bar, B bar and C bar. That is, R bar can be written as X A bar plus Y B bar plus Z C bar, where X, Y and Z are scalars. Okay. So now what we basically have to do, now we have to simplify our equation. So even we will require one more thing, as we can see that there is a cross product of three vectors. Like earlier in the starting we have A bar cross bracket is an R bar minus B bar cross A bar. So we have a formula for vector product of three vectors. Vector product of three vectors. So the formula is A bar cross product with B bar cross C bar. So this is equals to A bar dot C bar. This is a scalar, B bar minus A bar dot product with B bar C bar. Similarly, we have A bar cross B bar cross product with C bar is equals to, it's going to be A bar dot C bar B bar minus B bar dot C bar A bar. So this is a formula for calculating vector product of three vectors. So now let's start with the given equation. So this is the given equation. So now we are going to use above formula, which is the formula of vector product of three vectors, to simplify this. So by using above formula, what we get is A bar dot A bar into R bar minus B bar minus, it's a bar dot R bar minus B bar A bar plus B bar dot B bar bracket R bar minus C bar minus, it's a B bar dot R bar minus C bar B bar plus C bar dot C bar R bar minus A bar minus C bar dot R bar minus A bar C bar. This is equals to 0. So we just have to apply above formula 3 times. So now, as we can see that we have A bar dot A bar, we have A bar dot B bar, B bar dot B bar, and we have C bar dot C bar. So we know that A bar dot A bar is nothing but A bar dot A bar. We have A bar dot A bar is equals to magnitude of A bar square. So this is going to be equals to magnitude of B bar square because it's given in the question, and this is equals to magnitude of C bar square. So this is given. Okay, so now what we get? We get a bar dot a bar, it's a magnitude of a bar square bracket r bar minus b bar plus, I'm writing this the addition term first. So it's a b bar dot b bar, so it's a mod of a bar square bracket r bar minus c bar, and the second last term which is plus c bar dot c bar, which is mod of a bar square r bar minus a bar. Okay, so then minus, then what we have, it's a minus. Then we have minus times bracket a bar dot r bar minus, see here we have a bar dot r bar minus a bar dot b bar, but we know that a bar dot b bar is 0, so we are just left with a bar dot r bar. Okay, or else we will just write it down a bar dot b bar. Then we have a bar here minus b bar dot r bar minus b bar dot c bar. Again this b bar dot c bar is going to become 0, b bar plus, sorry, it's a minus, then it's a c bar dot c bar, c bar dot r bar minus c bar dot a bar c bar. Again the c bar dot a bar is going to be 0, this is equals to 0. So from the first three terms we can take mod of a bar square, magnitude of a bar square bracket, we are taking it common, so we have 3 r bar minus bracket a bar plus b bar plus c bar. Okay, this is from the first three terms. Then we can take minus common, we can take actually minus common from the three terms, the last three terms. Then what we have, as I said, that a bar dot b bar is 0, b bar dot c bar is 0, and c bar dot a bar is 0. So we are left with a bar dot r bar a bar. Okay, a bar dot r bar is a scalar multiplied to the vector a bar minus, so it's become plus because we have taken minus sign common. We have b bar dot r bar b bar, then plus c bar dot r bar c bar, because c bar minus a bar is 0. Now this is equals to 0. So now we have mod of a bar square bracket 3 r bar minus a bar plus b bar plus c bar minus bracket. Now let's calculate what is a bar dot r bar. As I said that as a bar, b bar, c bar are three mutually perpendicular vectors, then any vector r bar can be written as a linear combination of a bar, b bar and c bar. So now we have the value of r bar in the terms of a bar, b bar and c bar. So if we want to calculate a bar dot r bar, so it's going to be a bar dot r bar is x a bar plus y b bar plus z c bar. Now it's going to be a bar dot x is a scalar, so it's going to be x times a bar dot a bar, then plus y is a scalar, so it's going to be a bar dot b bar by using the properties of dot product or the distribution of dot product over the addition. So a bar dot b bar is going to be 0, again a bar dot c bar is going to be 0. So what we are left with, x a bar dot a bar. So then what is this? This is nothing but x times mod of a bar square. Okay, so here we get mod of a bar square. Okay, this is x times and we have a bar. Similarly, plus we get y times mod of a bar square, then it's a b bar plus z times mod of a bar square C bar. This is equals to 0. So the first term remains same minus. Now what we can do is we can take mod of A bar square common. Okay, so we take mod of A bar square common. So what we are left with, it's an X A bar. It's an X A bar plus Y B bar plus Z C bar. Okay, and this is equals to 0. The first step we have here. Okay, as it is. Now we can see that both the terms contains mod of A bar square. So we can take it common and we can just set it on the right hand side. So 0 upon mod of A bar square is going to be 0. So what we are left with? We are left with a 3R bar minus, it's a bar plus B bar plus C bar minus, it's an X A bar plus Y B bar plus Z C bar, which is nothing but R bar. This is equals to 0. Now we have 3R bar minus R bar. So it's going to be 2R bar, 2R bar, and we can send this A bar plus B bar plus C bar on the right hand side. So we have A bar plus B bar plus C bar. Okay, so the value of R bar turns out to be, it's a bar plus B bar plus C bar upon 2. So the value of R bar is A bar plus B bar plus C bar upon 2. So option A is correct. Thank you.